Hi, welcome to Expert Talk. This is the interview series with thought leaders in the analytics, AI, and transformation space. My name is Mahadevann Iyerr, Mahaa for short. I'm your host for today. I'm the co-founder and CEO of Intelligent Marketplace for On-Demand Actionable Analytics. Our guest for today is Rahul Pednekar. Rahul is the Vice President and Head of Advanced Data Analytics, Actuarial and Data Insights at Swiss Re. Prior to Swiss Re, Rahul has worked at Infosys, Morgan Chase, and Vodafone. Rahul also frequently participates in analytics and AI industry hackathons and speaks at industry seminars on the advancing role of AI. So Rahul, thank you so much for making time and joining us for this chat.
Yeah, thanks a lot, Mahadevan. First of all, very good evening to you. And thanks a lot for inviting me in the Experts Talk. I'm really glad to be here and looking forward to a wonderful session with you.
Thank you. Thank you so much. So Rahul, you're someone who started with Infosys in the programming technology space. Then you moved to, JP Morgan, then to Vodafone, and now with Swiss Re, right? And you've traversed the journey from technology to analytics to advanced data analytics, right? So it would be good to understand from you, how did you go about making this change? What are some of the intrinsic or innate skills that you had that helped you? What are some of the skills or learnings that you developed to be successful in your journey so far?
Yeah, sure. So I graduated in the year 2002 as a computer engineer from Mumbai. And then I joined Infosys and I worked in Infosys for around 6.5 years. And initially I was a developer. So I worked on C, the various variants of C like Pro C, eSQL C, on PL SQL, Oracle database. And I was a programmer when I started my career. I also worked on Java applications. Which were deployed on the Unix platforms. Then I also, after 6 years, I moved and I joined JP Morgan Chase. So in JP Morgan Chase, I worked again on the Java J2 applications on the Unix platform. And then I worked with Vodafone for around 8 years or so. And that was the time when actually I started developing interest in the data analytics. So I attended a course from IIT Madras. And that course really inspired me or motivated me to move into the analytics domain. So since my school days I was quite passionate about mathematics, and I had developed the liking for programming throughout my corporate journey. And I think data science is it's an intersection of computer science, statistics, mathematics, and domain expertise. So that course really inspired me, and then I decided to transition from the IT background to the analytics background.
Nice. And obviously in Vodafone you were in the analytics side of it, and now you're in advanced data analytics. Was it just gradual in terms of trying to do more high deep learning, high impact type of work, or how was it?
Yeah, so I also started taking part in various hackathons when I was with Vodafone, and I always advise to all the new aspirants that you should not work in silos. If you work as a data scientist in silos, you may not learn as much as you can learn when you actually work with other data scientists and collaborate with them. So there are various open AI platforms available online, wherein you can actually collaborate with other data scientists and learn the various tools or strategies that they are using. At the same time, you can contribute on those open channels. So by asking questions or answering questions on the forums, discussion forums, where other data scientists may need your help, or you may need help from them. So always contribute on those channels. And at the same time, whenever you learn something new, or achieve something new, always make sure that, you leave a digital footprint on the online channel. So, make a post on the social media, And that will not only give you more confidence, but also inspire others, to learn from you.
Oh, absolutely. Brilliant. I think very well articulated. Nice. So now the other part is, so you moved Infosys IT services company and then JP Morgan Chase into financial services, Vodafone telecom company, and Swiss Re now into insurance and reinsurance, right? And one of the things we keep saying in data analytics is context is the most important stuff, right? So how have you been able to build the business context? What are some of the initiatives or approaches that you have taken to ensure that you are able to understand a lot more about the business and create value through analytics?
Yeah, so I think domain is one of the most important aspects, for any data scientists. And without domain expertise, what we see is only numbers. So a data scientist, if he works in silos, and thinks that the model will give the best output, I don't think that is possible. You need to, first of all, understand the domain. You need to understand, the intricacies and the details of the domain, you should not just rely only on the the predictions given by the model. You should there are two things that I did. So the first one was, you should learn on your own. If it is insurance domain, there are various domain related articles or websites available online, so you can go through them. You can also learn how to do insurance domain specific modeling. uh, uh, in insurance domain, it is not just the Python language, but R language is quite widely used, and there is a different kind of modeling, done by all the actuaries. So how do they do, modeling in R? That is also one of the most important things that I had to learn. Being a Python. Being having a background in the Python language, it did not take much time for me to learn R, but how the mathematical modeling or statistical modeling is done using R language for insurance domain. That was the first thing I learned. And second thing is, you need to make friends, with the domain expertise. So somebody who is actually working, in the insurance domain and has in and out knowledge of economics as well as statistics, as well as how insurance company works. So, and, understanding, the details of this insurance business was the second thing that I did, by, making more friends in the insurance industry. So yeah, so domain knowledge is, much important, and other without the help of domain knowledge, what the model will predict is just numbers. It will not have any value.
Oh, absolutely. Very nicely articulated. Now, so in any organization, right? So there is a need for quick turnaround analytics because business is facing a particular challenge. They are looking to understand some insights, take some actions, right? Which can be possibly near about accurate, but it's okay for them because they want to act on it, right? And on the other side, there are transformational projects which are, you build recommendation models and then you integrate it with digital systems. And then, that's a larger transformation, right? And you have had experience of, while on the analytics side, you have worked with both Vodafone and, Swiss Re, right? What has been your experience, right? How is this whole thing in terms of split between quick turnaround analytics and deep learning, AI, ML, ops type of projects? How is the split really moving? Is it?
Yeah, so I have most of the time worked on the classical machine learning, and I know deep learning. I have experienced it. I have experience of using deep learning, but on the professional side, I have only worked on the classical modeling, on the statistical data. So by classical modeling, I mean it's on the structured data, where you have a structured data and not images or pictures. Uh, so I would say, it's very important to build a prototype first. Whenever you are given a business problem, try to articulate that business problem as a machine learning problem. So, for example, if you want to build a recommender system, okay, if I define the problem statement like, build a recommender system which will uh, increase the net revenue. So that will definitely not be the correct one, because we know that the click-through rate is one of the most important parameters, when it comes to a recommender system, and how to evaluate, the impact of this recommender system is via click-through rate. So, defining the problem, with the correct keywords is very, very important. And one idea would be to build a small prototype. So when you build a small prototype, you understand, 2, 3 aspects. So the first one is availability of data. So are you going to get the data available? When you actually do the forecasting, let's say you want to forecast sales volume for next 5 years, do you have the data available or not? Or let's say you are building a machine learning model to predict the GDP for next 5 years for a country. And let's say forecasting GDP requires another 5 set of variables, for example, consumer pricing index or low wage index or unemployment rate. Uh, do we have that data available, first of all? If that data is available, how many rows are available, because any machine learning model would require huge amount of data. And when you talk about GDP, CPI, etc., you have yearly data, so you may not have more than 30-35 rows of data available. So building a quick prototype definitely helps. I would also suggest that we should involve the business users when you are building the quick prototype, because you also get the buy-in from the business users, and they also feel a sense of ownership, when they are involved. In defining the business problem and building the quick prototype, because finally they are going to use it. And once you build a quick prototype, you demonstrate that to the business, and once they agree, then you actually start building the big model, wherein you have a proper plan of building a plan for having a data engineering team who can build the entire pipeline. Then you have data scientists who can build the model, and then you have ML engineers who will deploy the model and expose it as a web service, generate an endpoint, which will finally given to the IT team who can build a good UI. And then we can scale it using any of the cloud environments, and finally the business can consume it.
Oh, nicely articulated. So, yeah, the prototype actually, in a sense, helps to get a business buy-in. It gives a sense of, the level of data availability, possibly the level of input factors where you have data and all that. And, the whole journey of building a prototype through to, deployment through IT. Yeah, very nicely explained. Thank you. Now, in today, we are saying we are every company is a data company. Everybody is now capturing a lot more data. So there is a lot of internal data available, right? So can you talk of your experience of how you've been able to assimilate external third party or auxiliary data and make more sense of it?
Yes, I agree with this point. So internal data is always available, but there is always a challenge in getting the external data. As I explained, like let's say you are forecasting, the GDP for the next 5 years. First of all, you need to have the GDP, the historic GDP available for last 30 years or so. And similarly, there are various macroeconomic indicators. So they are also, they should be available. But what about the forecasted data? Now, you may not have the forecasted data for various input parameters, which are prime indicators for predicting GDP. And that's where the external agencies come into picture. So we can take data from the external agencies like Moody's. So Moody's rating agency is one of them. Then we also have Bloomberg, from which we can download the data. So there may be scenarios where the real world data is not at all available. So for example, let's say you want to predict the loss for airline industry, and you want to have the details of various aircrafts, the length of the aircraft, the breadth, the age, the pilot name, the country to which he belongs to, the country who manufactured this particular aircraft, and uh, has it undergone any losses in the past. So all this data will not be available as your internal data, and you will definitely have to source it from the external world. Same is true for the cargo ships. If you want to have data for different types of cargo ships, and their age and the captain details, the manufacturer of those ships, those vessels, and you want to build a model to predict what would be the loss that they may incur in the future, what would be the route that they would be taking in. uh, so external data plays a major role, and either so one way is you buy it if it is possible. If it is not possible, you can look at the external agencies who provide the data for free, like Moody is one of them, Bloomberg is that one of them. Yeah, but yeah, external data is very important.
Got it. Got it. Now, as we, as we have started moving through, from basic data analytics, which was essentially statistical driven and looking at sample and cause, understanding causal relationships, then we move to ML, which is a lot more of modeling. Now you're getting to deep learning. And one of the challenges is what we call as explainability, right? In a decision tree, the explainability to business is a lot more easier compared to what a deep learning or a neural network throws out, right? The accuracy of a deep learning or a neural network or even an ML model like random forest could be far higher than a decision tree, or maybe but then while the the predictability, the results will be far better. The explainability is gets reduced. Now, when interacting with business always has the challenge that why is this happening, and because they want to know what are the input factors that they can control, based on which they can actually manage the outcomes, right? So there could be reasons for justifying something, for controlling something. There could be regulatory reasons why somebody needs to be able to explain the key factors, right? And this is becoming a key challenge, right? So while black box can throw great results, businesses still have this challenge from a regulatory control justification perspective. So what is your own viewpoint on, how do you think this whole explainability is taking center stage? And if we start moving more towards explainable AI, explainable ML, is it likely that the input factors will have to be reduced, which essentially means that the predictability or the efficacy of that model will start reducing? So, have you come across these examples, or what are your thoughts on them?
Yeah, I think interpretability and justifiability are the most important factors, because just imagine that you build a machine learning model, with sophisticated tools and technologies, and then you have a presentation with the business, and they don't understand anything, on the technology side, and for them everything is a black box. So they will tell you that I don't understand, why the model has predicted this value. Explain. And that is the most difficult part, bridging the gap between the technology and the business. And if one is not able to do that, then it is very difficult to convince the business to buy the product. So by explainability, I mean that your machine learning model should be understandable by the business domain expert. And by justifiability, I mean that the uh, the business outcome of that model should be as per the expectation of the domain expert. Okay, so let's say you are talking about, let's say you are predicting, the probability of default, in case of credit risk modeling. You are doing credit risk modeling and you want to predict what would be the probability of default, next 5 years. So we know that, let's say the real GDP, goes down, then the probability of, default may increase. So there is a, inverse proportion between these two. And if you are able to justify that, if the model is able to justify that, yes, because GDP is one of the important factors, and if the GDP is forecasted, GDP is going down for next 5 years or next year, definitely the probability of default may go up. So that's what I mean by justifiability. And by explainability, you have various tools, like we have Sharply or we have Lime, and there are a few other tools using which you can actually explain, why a model is predicting in a certain way. Sharply will, assign individual values to each of those features, and you can see, which of the features are moving the score towards positive end and which are the scores which are moving the score to the negative end, and why a particular model has predicted, in a particular way. You can also show, a global feature importance using sharply, like let's say out of 10 features, these are the top 5 features. You can also show the feature importance at each row level. So for this particular row, what was the sharply score for each of the features, and why did you get a particular, final score for this particular row using sharply. So definitely, I mean, interpretability, I think it is one of the most important things, and that bridges the gap between technology and business.
Nice. Okay. Now, there's also the other thing, when initial days there was just DevOps, and now, people talk of ML ops, right? There is data ops, there is ML ops, there is platform ops, right? So everybody is, and there are a lot of jargons getting thrown around. So just how do you, in your own mind, and you very nicely explained in terms of prototype to deployment, what is the journey typically traverses. So in your mind, where does this whole, is it just another jargon, or are they really integrated in the way it works? And people also talk of extended ops today, right? So if you can just explain, your own viewpoint on that.
Yeah, so there are, I think, various terminologies that have come up, and new terminologies are still, coming up. So ML ops is now similar to what we have, data ops in IT, and then we have data ops, which is again a new term. So as a data scientist, I always tell my team that we have to be generalist, which means we need to understand data engineering part well. Uh, Data science part well, as well as the last part, that is ML ops, as well as data ops very well. Uh, Otherwise, a data scientist will only write code which will, stay in the Jupyter notebook. It will not be productionized and it will not be used by anybody else. So learning ML ops, how to deploy or and productionize your application is one of the most important aspects. And at the same time, data ops, which gives more importance to the data than, giving more importance to the model. And that is also a new concept which has come up, and that is also interesting one. But yes, having a knowledge of, how to expose your ML model as a web service, and generating an endpoint, which is a part of ML ops, is, very critical to productionize the model. And data ops, I think it relates more to the data, and I always believe that no, it is always the data, which dictates everything or dominates everything. It is never the ML algorithm. It is all about the quality of the data that you have. If you put garbage in, you will get garbage out. So the data, has to be cleaned. It has to be, prepared well for the model. It should make sense. It should be available. That is another challenge, that in most of the cases in real world, the data is not at all available. If it is available, it may be wrong. So availability of data, which is covered as a part of the data engineer by the data engineering team, and then deployment of these applications, using ML ops, are, critical to the success of any analytics project.
Okay, nice. So now I'll come to the next question, which is now OpenAI. Everybody's talking of OpenAI, ChatGPT, Delhi 2, and all the stuff is coming. And now Google says I've got Bard. OpenAI is integrating with Bing, right? And as it is, there are a lot of low code and no code platforms coming. And the general feel given to people like me who are more on the business side of things is that, okay, technology is important, but you can overcome it if you have the right context, if you know what is the problem you're trying to solve, and you know the questions you want to ask, right? Data analytics and insights and ability to take decisions is going to become increasingly easy, right? So what's your own perspective on that? Is it already there? Is it some time away? Do you do you see the data data analytics ecosystem as it exists today, like data engineers and data scientists and ML ops engineers and all that, with the increasing use of black box, for lack of a better word, right? And business is able to trial and see, okay, and I'm the decision maker, I can take a decision type of stuff. If that were to happen, do you see the ecosystem as it exists currently getting disrupted, or you see that they will all coexist? What is your thought on how the future is likely to pan out?
Yeah, Chat GPT, I think, or OpenAI, they definitely have, a big, I would say it's the next big thing for the business transformations. And now with Chat GPT, the machine learning models are being more and more creative. They are able to generate, the text. So given few words, they are able to, write screenplays, or they are able to write poems. And yeah, definitely it's going to be one of the next big thing. uh, there are many questions that come to my mind, and there are many challenges as well. So the first thing is, there may be ethical concerns surrounding the use of AI in business, because these systems can have potential biases. Then again, training and fine tuning the model may require significant data and computing power. And implementing chat gpt kind of applications into the business system settings can be really complex, and may require a substantial investment in terms of time and resources. Another question can be that, will AI based chatbots replace jobs? So I don't think they can replace all the jobs. Probably they can automate some of the tasks, but they are not capable of many skills that the people are great at. Like critical thinking or strategic decision making. Chatbots can be used to supplement customer service staff, allowing people to focus more on the complex and more of human tasks. I also have a food for thought here. So imagine that, the implications, if every student, is writing an essay, which uses Chat GPT to generate the text. And every software company is using Chat GPT to create or write the code. And every social media channel is clogged, with responses created by Chat GPT and so on. So, what will this do to many of our knowledge-based professions? What are the implications for the intellectual properties, where we cannot distinguish whether the information generated is by human or by a chatbot? And then how are we going to evaluate the value and validity of these AI generated responses? And there are many other questions which are still left hanging in the air. So I strongly believe that most organizations as of today are completely unprepared for the impact of chat gpt. Nobody knows what is going to be the impact. Nobody is prepared. And I had been always a strong advocate of using AI for humanity. And it will only happen if when you and your coworker work together as partners. Your AI coworker and you work together as partners. Now, there are certain things that humans are extremely good at, and there are certain things that machines are extremely good at. So if we put these two things together in a good way, then you will get a superhuman.
Yeah, absolutely agree. So, that brings me to my next question, right? From a, like you said, in the future of AI, there are certain tasks which are repeatable in nature, which can possibly get automated, right? And there are certain places where, the human touch, the human, ingenuity, creativity is required to really, ask those questions and think differently and, use the AI, right? So both of them have to coexist. Now, also on the future of work front, something is happening. There is a lot more of work anywhere, work anytime, work when available type of stuff that is happening. There is a, in the knowledge space, at least, there's a lot more of migration happening to freelancing, part-time freelancing, flexibility of work and all that, right? Um, so where do you see this? Do you see somewhere where future of AI, where more and more, if you have the context and the ability to understand a little more and explainability is there, people will be able to do work from anywhere, and which means the future of AI will in some way influence the future of work to be more on demand when required, collaborating with external environments. Do you see that happening, or do you what's your thought on that?
I think there are possibilities that it may happen in the near future due to the COVID era. We have seen, most of the people were working from home, and now nobody has to, be in office for like all 7 days or 5 days in a week. So, and with the help of AI, I think it can be enhanced further. So, we can utilize AI, for the customer support or for the clinical trials or in the education system wherein, you don't need a physical presence. It can be done, over computer online. So yeah, there is a possibility, but to a limited extent. As of now, I see it as a limited extent in the future.
So, Rahul, what would be your top three advice be to a 18-year-old who is aspiring to make a career in data analytics? What are the three things you think she or he should, focus on and learn, or which they feel which can make them successful in this profession?
Yeah. So data science is a pursuit of curiosity. So you have to be curious. You have to learn new things. The field is evolving so fast, so you need to keep yourself updated with the latest things. The second point would be, build a solid statistical knowledge. Without having a good statistical knowledge and learning only Python and other languages will not make somebody a great data scientist. I'll give you one example. So let's say, you are predicting a probability of credit default. Now we know that probability lies between 0 and 1. And if you use, let's say, a basic linear regression algorithm to predict, the probability, which is a continuous random variable between 0 and 1, it may give you negative results or it may give you positive results because it is not bound between 0 and 1. So without having understanding of the statistical distribution of the probability of credit default, it will be very difficult to decide which algorithm should be used for this particular task. I have seen many data scientists, they use the latest gradient boosting algorithms for this task, and then they will, it will predict negative values or positive values greater than 1, and then they will just replace it, with 0. So my suggestion would be, understand what kind of statistical distribution the data is following. Is it a Poisson distribution, inverse gamma, Pareto? So you need to have a good understanding of the distribution and the statistics, behind the data. Uh, the third one is, as I mentioned, you have to collaborate, contribute, and leave a digital footprint. So, work with other data scientists, learn from them, contribute on the open platforms, as well as, make your achievements visible on the social media and leave a digital footprint. And the last one is there are three pillars of data analytics. So the first one is data engineering, the second one is data science, and third one is ML ops. So one has to be a generalist and master all these three fields. And the aim should be to productionize the application or the model that you have built. Try to build a prototype first, and if possible, try to make a product out of it by productionizing. So being a generalist and learning all the three pillars is really important. So that would be my advice to the 18-year-old.
Nice. So you're saying keep staying curious, know statistics from first principles, so you know what you are applying when, right?
Yeah.
Uh, right. The third part is in terms of knowing the whole thing end to end, in terms of be a generalist, so you know the end to end process of data engineering through data sciences to ML ops deployment. And the fourth one is essentially always be open to collaboration, sharing, and learning. And
Yes.
brilliant, very nicely articulated. So, Rahul, it's been a pleasure talking to you.
Yeah,
and
same here.
listening to your practical thoughts in terms of how to approach analytics and ML ops. Um, and once again, thank you for making time.
Yeah, it was great talking to you as well, Mahadevan, and thanks a lot for this opportunity. And I had a great time in this session. Thank you once again.
Thank you.
Yeah, thank you. Bye.